But the guys that came up with this model also had to explain some other things. They had to explain, because of what we see in the magnetic field lines, how did this one continent get ripped apart? We have to explain, how did we get magnetic reversals in the middle of the ocean? Remember, in the mid-Atlantic ridge, you learned this in physical sciences last year, I think. You learned slightly about magnetic field lines. You guys didn't get into that in great detail. But the mid-Atlantic ridge, if you actually are to look at the magnetic field lines in the rocks, remember I told you as rocks are laid down, they take on the magnetic field of the Earth at that time. What they found was when you look at the rocks in here, and you look like you take cut through the rocks, let's say you cut through them this way, what they saw was zebra stripes. So there's spreading going on here. So there's actually a mountain range on either side of this, and that's what this is, okay? And as they looked at the rocks, what they found was zebra striping. Positive magnetic field lines and then negative magnetic field lines. And how is that interpreted scientifically? That means that if you had a compass, the evolutionists would tell you over millions of years the compass would have gone from the North Pole area to the South Pole area, and then it would go back to the North Pole area again. It tells them there were magnetic reversals. The magnetic field of the Earth reversed several times because we see stripes in the mid-Atlantic ridge. We see stripes of this. So that means that this rock was laid down, and at the time that it was laid down, at one point it was north was pointing north, and the other it was pointing south. Now, what do we believe? Well, we had to explain that in lieu of what the Bible tells us. And the Bible does tell us that the Earth is approximately 6,000 years old and that the flood occurred approximately 4,500 years ago. So how can we explain those magnetic reversals? Well, what they said was, as those pieces of rock were being sucked into the mantle. You see on the left-hand side, there's a little piece of crust being pulled in. As the crust is being sucked into the mantle, and it eventually gets down near the core of the Earth, the outer core, where the flow of iron, the liquid iron is, what it would do is it would cause temperature gradients in there. So there'd be hotter areas and colder areas, and it would cause the magnetic field of the Earth to flip-flop back and forth. Back and forth. So if you and I were standing on Noah's Ark and we had a compass, our compass would have gone north, south, probably about every 10 days it would have flip-flopped. Okay? It would have flip-flopped relatively quickly. And that's the magnetic reversals, the zebra stripes that we see in the mid-Atlantic ridge. So in other words, Jessica, creation scientists had to look at that evidence and go, now how can that fit into the flood? That's where they came up with the model. Does that make sense?
What I was saying is like, you said, new crust was created, it expanded, and then it,
Oh, that part is just physics. We know that when rock comes out, it's thicker, and when it cools, it's thinner.
Yeah, I was, like you said, the tsunami storm or whatever it was that happened recently, they're not just making an assumption after, just a little pop in the crust, they're not just saying, oh, put that on a bigger scale. That's what happened. Yes, they are. They definitely are. Absolutely. You definitely are, because otherwise we don't know how to interpret what those things would do. But as we see them happening on a smaller scale, then we know at least this is what comes out of those things. Okay. Absolutely. And that's why it's scientific interpretation, and the parts that are Bible are true and the parts that are interpretation you're not always sure of. Absolutely. Because we have to take what we can actually see, smell, taste, hear, and touch, and then try to interpret it the best we can, because we're going back to the past, aren't we? Right? You are right about that. You're absolutely right. And that's why I always tell you the parts you can actually bank on are scripture, and the other parts, yeah, I started to tell you before, as I wrote that book on the geologic column, they were trying to figure out where the end of the flood was in the rocks. That was the current issue going on within creation science at the time. Now that was back in the 1980s. Late 80s, early 90s. Let me think. It was in the 90s. But they were trying to figure out where the end of the flood was in the rocks. Now, I'm going to tell you today where creation scientists think the end of the flood was in the rock. We think it's at the Catie boundary. But I read all these articles because they kept going back and forth, and one guy would say, well, wait, we see this, and the other guy would say, no, wait, we see this. And we all agreed on the Bible, but we're all trying to figure out the scientific evidence. See, this is why when that lady says you're not real scientists, it makes me laugh, because I've seen these scientific issues go through the scientific community and how people go back and forth
forth trying to figure out, well, how would you interpret that? And don't think the evolutionists don't do the same thing. They do. That's why we have like the faint sun paradox and Carl Sagan trying to figure out how do we explain that one. We all have the same issues with science. The benefit we have is that we have God's word, so we know that part is true. They don't even have that benefit. It's kind of like cheating. It's like having the answer book over here, you know? So anyway, I'm not going to feel guilty though. Okay, so from this, what scientists do, and you learned this in physical science this past year, is they have to make predictions. Because when you put forth a scientific model about the only thing you can do, unless somehow we could go back in time to see what happened, is make a prediction about what you expect to see. And these 6 gentlemen made this prediction that there should still be pieces of the ocean floor down near the mantle core border where these two come together, because they said it was only 4,500 years ago when you get these big pieces of ocean floor being sucked into the mantle, they wouldn't have time to completely melt in just 4,500 years. The evolutionists think this happened millions and millions of years ago, and therefore there should be no big plates left. And yet they found pieces, big pieces of oceanic plate at the mantle core boundary. Now immediately, first thing that ran through my mind is, how'd they find that? You know, that's a long way down there, and nobody can go down there, so it's got to be by seismic measurements that they have found that. But the point is they found supporting evidence. The same is true for those of you that already took physical science when we looked at the magnetic field of the Earth, and when Dr. Russ Humphreys put that out there, and then they checked the magnetic field of Mercury, and they checked the magnetic field of Uranus and Neptune, and they all supported the predictions that Russ Humphrey made with the rapid decay theory. That's how scientists have to test their theories. It's about the best we've got. Because we're trying, you can't go back to the past, can you? Okay, when the seafloors cooled, and once again, this is based on physics. This is not based upon the Bible. This is based on what we see now. When it would have cooled, it would have sunk down into the mantle, and that would have allowed the waters to run off between the 3 to 4 feet of water, between the tsunamis and between the water running back into the basins that it belongs in. We would have catastrophic erosion, which would have literally ripped apart the pre-flood world and carried it someplace else and laid down that strata, one layer upon another, like wet cement. These are people in France. You're looking down at the people. They're collecting fossils. And what I want you to see is it looks like one sidewalk layer on top of another that's been layered there, doesn't it? And that's rock strata. And that's why we see this, is because when the flood was occurring, it was literally ripping apart the pre-flood world and carrying it with currents someplace else. As that happens, things turn into fossils. And you can get all sorts of interesting fossils. You've already seen the ammonite. Here's a clam. Here's a fish fossil, okay, and there's just a little fish there. You guys see these in your driveway all the time. This is actually a dinosaur gastrolith, that's what I was told, which is a stomach stone. If you break down the word gastrolith, you know how birds have rocks in their gizzards? They believe that that's what the dinosaurs had, rocks in their area too, so it's a gastrolith, okay? But anyway, it just, you know, they even sell dinosaur doo-doo. It's called coprolite, but it's another story. Okay, so the point is that fossils were formed. Now, if that fish that you're passing around just died, let's say in your fish tank, he would not have turned into a rock, would he? No, he'd start to rot. The other fish would try to eat him. He'd float to the top. He'd be gross, you know. Or if your pet frog died and you put him in the yard, he would not turn into a rock. He'd be an ant pile tomorrow. The dog would go roll in him, or vultures would come eat him. Something would happen. He would not turn into a rock. For things to be fossilized, floods are the best way to explain it, because the water covers them and the sediments are carried in the water, and then the minerals can go in and out and replace the living tissue and turn it actually into rock, or leave the impression of the once living thing. And when you cover it with water and the sediments, the vultures can't get to it, the red ants can't get to it, your dog can't get to it, you know what I'm saying? And so that way it has time to go through the petrification process. So the flood is a good explanation of this. As the sediments are coming in, clams aren't very fast, so they get buried first. They're at the bottom of the ocean, they get buried first. Then more sediments are coming in, Fish would be buried next. I want you to notice both of these pictures of fossilized fish have dinner hanging out of their mouth still. And if you've ever seen a fish eat, they swallow fast, don't they? Which means these guys had to be buried pretty quickly to get like a photograph of them in the fossil record actually in the process of eating. And so it's not this long, slow stuff that the evolutionists tell us about, like it went down to the creek and it fell in and it turned into a rock. I don't think so. That's not observable science. But if this guy was in the process of eating and whoom, you had like this turbidity current coming full of sediments underwater and just cover this guy, then I would explain why we see that. And as that keeps going up and up and up, you'd eventually start catching the swamp critters like alligators and crocodiles and then frogs and things that live in the swampy areas because the water's rising. And then eventually you would get inland because eventually the sediments in the water are catching the things that are living inland and pulling them out and burying them. And that's exactly what we see in the fossil record. Yes, ma'am?
This fish right here, is that just an impression?
Yep, and certain fossils are just impressions. Certain fossils are mummification. That freaked me out when I heard about that.
So what happens to the actual fish?
It would dissolve and disappear at a point. Yeah. There's like 5 different kinds of fossils, if I remember correctly. And yeah, some of them are like imprints. Leaf imprints are cool. And then the leaf's gone, but they'll leave like the imprint.
So it was covered in sediment and then there was an impression left in the rock and everything.
Right.
But the bones actually just...
Well, in some cases, the bones fossilize. It depends on the type of fossil. Absolutely. It depends on the type of fossil.
Where was this found?
Out west, they have a whole bunch of those. Okay. Like whole areas are just full of them. Up in the mountains, which I think is rather comical. They find whole slabs of rock that are just full of these fish. You can just set it down when you're done. And what we find worldwide is we find a mile deep of sedimentary rock full of fossils. And the cute part is that these rocks are, these strata, the rock strata, the layers are actually, they go across the whole planet. They literally go across the planet. Now, why would they do that? Because it was a world-covering flood. It wasn't a local flood, and that's exactly why we see that. I actually looked this morning. There's called 6 megastructures in North America, which are these huge layers of different types of rock that go across the entire continent, okay? And it's because it was a global flood. So when you see this is the continent, this is the geologic column. We see the rocks and the fossils, and we see them worldwide. We see over a mile deep of sedimentary rock laid down by water, worldwide, full of fossils, okay? We say, okay, well, when we see that, that's evidence of the flood. That's how that was laid down. We think that there's a basic order because of where something lived, like the clam being at the bottom and the fish being a little higher and the alligators and stuff being higher and the land critters being higher. We believe that that's because of where something lived, how fast it could get out of the way, and the fact that water sorts things. When things float around in water, they sort things out, kind of like